Okay, welcome back. So where are we? Just a quick recap. You don't have to redraw this if you don't want to. Just a quick recap of what's going on. We've got a function. The whole thing is f of x. I'm going to have a point P. Well, I am going to have a point P. And here's my point P. And I want to come up with the slope of the tangent at P. There it is. I want to come up with the slope of the tangent. By definition, the slope of the tangent at P, at this point P, is going to equal the limit of delta x approaching 0 of the secant, which will be between 2 points on the curve. That's the slope of the secant. This is the slope of the tangent that I want. So it's going to be the limit of the slope of the secant. AB, or sorry, PQ. I don't know why I'm using AB. PQ, where now P is going to be given by x and f of x. Q is going to be given by x plus delta x. So it's just some distance down the road in the domain. So its range value is f of x plus delta x. So the slope of a secant is delta y over delta x. So this is my delta y. So it's going to be the limit as delta x approaches 0 of y2 minus y1 over x2 minus x1. I don't have to write that ever again. I just did that so I didn't lose anyone. So you understood I'm going from here to here. And then my y2 in this case is f of x plus delta x. My y1 is f of x. My x2 is going to be x plus delta x. And my x1 is x. And this gives us the limit as delta x approaches 0 of x plus delta x minus f of x over delta x. And that is, by definition, the slope of the tangent at P. Now, we use this concept so much that it has a special name. We call the result of this process the derivative. That's what a derivative is. So, the slope of the tangent of f of x of a, so when we say the slope of the tangent to f at a, what we could also say, or what we mean, is the derivative of f. Why don't I make that f of x so that you know that it's a function? Of f of x at a. Those mean the same thing. And we have a mathematical way of saying the derivative. And the mathematical way of saying the derivative is to say f prime. And to say the derivative of f of x at a is to say f prime at a. All these mean the same thing. And this is read, the way that you read this is f prime at a. And all of those mean the exact same thing. The slope of the tangent to f of x at a point A is also called the derivative of f of x at A. And if I want to write it in math speak, I'm going to write it like this. F with a little symbol up there, f prime at A. All of those mean the same thing. Okay? So we have a definition. Let f be a function the derivative of f at x equals a, denoted as, or written as, f prime of a, is defined by f prime of a equals the limit as delta x approaches 0 of x plus delta x minus f of x over top of delta x. Provided, now this is important, that the limit exists. And that is a definition. Now, it could be that someone wants to write this definition like this. And I will at different times write it like this. There is no difference. Okay? There's no difference if I use h to represent the little bit that I move down the road, or if I use delta x to represent the little bit that I move down the road. Okay, so let's do some examples. Well, just before we do some examples, let me tell you what this is. This is, what does this mean? This means the slope of the tangent to the function f at x equals a. That's what that means. And you would read it as f prime of a. And I think I've gone through that before. And once again, just to beat a dead horse, let's say I have a point here of x. Let's say I have a point here of x plus delta x. This is f of x. This is f of x plus delta x. You can't see. There you go. So the slope of the secant is given by f of x plus h. Oh no, I used delta x. X plus delta x minus f of x over delta x. So that's the slope of the secant. Whereas the slope of the tangent at P is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Do you see the difference? This one is instantaneous. This is the slope of a tangent. This one is average rate of change. This is the slope of a secant. There's a big difference in adding that limit, isn't there? It changes things immensely. What you're doing is you're taking this distance and making delta x approach 0. In other words, you're bringing that q onto P so that it is pretty darn close Never, ever, ever equal to just 1 point, but pretty darn close to just 1 point. And I think that's it for that. Let's do some examples. I'll pause the video here and I'll be right back.